Chapter 9, repeating with loops. So this idea is that you can execute the same code over and over again. So I'll do a little refresher on some of the operators we had discussed in a previous class that are relevant to how you set up a loop. The concept of iteration, what a for loop is, the primary type of loop you probably use most of the time. And then this idea of the accumulator pattern, a very common pattern for setting up a loop in some different applications. I'll give you some different examples for where you might do that with numbers or with strings. We're going to take a break and then we will come back with while loops, talk about user input validation, which is something, as Colin was just saying, that often you use while loops for. Talk about infinite loops. How do you create an infinite loop and what do you do to stop it? A nested loop and breaking out of loops if you want to just break it out, make it stop. Okay. So to refresh ourselves on these operators, we had this concept of incrementing and decrementing, where you can increase by one or decrease by one or another number, but by here we're doing it by one. And if you were to do it longhand, you could write it out this way, just say I want I to now have the value of I plus one, right? Or you could do shorthand. Does anybody remember what the shorthand is for incrementing?
We got an I plus plus.
Oh, that bit wrong way. There we go. Yes, I plus plus. Good. And then the same for decrementing. It is
Minus.
okay. I gotta get my keys sorted out here. There we go. I minus minus. Okay, great. And for additive reassignment, how do we do a shorthand for that?
What was that? X plus equals Y.
Yes, that's correct. And then, of course, similarly, with subtractive reassignment, you might say X minus equals Y. So these are some of the things that we often use in the process of loops. So you'll kind of see how I'm going to apply these things. But typically, you're going to want to just get in the habit of using the shorthand. That's what everybody does. Okay. So when you are iterating, this concept is that you want to be able to do the same thing over and over again, right? So you have some operation you want to do, and you want it to be performed on multiple elements of an array, or maybe like every character in a string, or maybe you're even just going from a range of one number to another number. So another application would be, maybe you want to search for multiple elements in an array and that have the same criteria and filter down, and get a subset that of just the things that match that criteria. And then, of course, the concept of validation. You can prevent your program from moving forward until the user has given you the type of input you're really looking for, which you can really use. Like maybe you're expecting a number and you need it to compute as a number, but they gave you a string or something like that. Something that can't be converted to a number, for example. So here's some examples. In this first one up here, I've got an array 2, 1, 4, 3, and 0. And when I get done looping through, I end up with an array of 4, 2, 8, 6, and 0. What would you imagine is the thing that I'm doing every time I loop to create, to get from here to here? Nobody? Okay. So each one of these elements has been multiplied by 2, right? So 2 times 2 is 4, and so on and so forth. So, I only really need to write that code once. I say I want to take that number and I want to multiply it by 2, and then I can apply it to every single element one after the other and create, maybe I'm just creating a new array and I'm pushing those values into my new array. Okay. What about this? Maybe I'm looping through a string, one character at a time. And when I start with this and ultimately get to this, what do you think my criteria probably is for building a string that only ends up with these?
What was that? Character is letter. Checking to see if each character is a letter, not a number.
Right, yeah, I'm gonna check for not a number, right? If I can't convert something to a number, then I want to keep it, right? And let's say we're looking for a two-digit number and we're just gonna look for one, and when we finally find one, we're gonna stop. So I could, iterate through this array. Is three a two-digit number? No, right? 597? Nope, not so much. So I keep going. Hello? Not a two-digit number. False, also not a two-digit number. And then I finally get to 42, and it is in fact a two-digit number. So I can, say, oh, I found it. Yeah, this is the idea. You have data, and you have data in either, a collection of characters in a string, or maybe a collection, like a list of elements in an array, and you need to be able to process all the way through them. This is what loops will help you do. Okay. So let's talk about the structure, just the syntax of setting up a loop. It's important to understand what all the different parts mean, so that when you are creating one for, on your own, you can create it exactly as you need it. So you always use the keyword for a for loop. And then you follow it by parentheses because you need to give it some information so it knows where to start and how long to go. So each of those things should be separated by semicolons. This is a short form of essentially 3 lines of code that are just, side by side here. So that's why the semicolons are there. It needs to execute each of these separately. The first one is the loop variable. It has to be declared and initialized. So you have to use that let keyword and give it, usually we use I for a single while loop. That's kind of common practice. And you want to start at some number. Maybe it's 0, maybe it's 1, maybe it's something else. And then you are going to have the loop condition. That's the second part here to say, how long should the loop continue? It's a Boolean expression. It should always evaluate to true or false. And it will keep looping as long as it's true. And then when it's false, it stops. The update expression is this last part here. That's to tell it, how much should you increase or decrease by to change the number so that you're ultimately progressing toward a finish. Because if it's the same every single time, you'll just infinitely loop, right? And then the last part is the loop body. You want to define this with curly braces, and it will have a block of code that should be executed every single time the loop iterates over and starts over. So I'm gonna go through in a minute kind of the sequence of how this code executes. But let's just repeat this again. So we have the keywords for, and we're also using let to initialize, declare and initialize this variable I. This loop variable is what we use to keep track of, where we are in the iterating. And the loop condition is a Boolean expression that tells us when we should finally, how long we should keep going. As long as this is true, we keep looping. When it turns false, we no longer are looping. And that's the update expression. Every single time we need to change it so that it'll keep moving forward. And then the loop body is where you put the code to execute. Okay. So the next thing to talk about here is, what is the sequence? How do I understand what's happening behind the scenes? Because this is nice, concise syntax, but there's a lot going on. So let's talk about this sequence. We're going to first have that loop variable be set, but that only happens the very first time, right? You just have to give it an initial value. So that's setting the loop variable. And when that's true, then we would say, okay, we're starting off with a value of 1, I is 1. Then every time we loop, we have a sequence, and it kind of cycles around. The loop condition will determine if it should continue. And so we evaluate, is 1 less than 3? And it's true, right? So we keep going. Then the code block executes, and we console log the value of I, which is currently 1. And then the update expression will then increase or decrease the loop variable depending on how you have it set up. And so we say, okay, I is now equal to 2. We can go back to the beginning and start over, right? So we evaluate with I is 2 and say, yep, 2 is still less than 3. Let's keep going. Then we console log the value of I, which is 2. And then we update it again and say I is 3. So when we get here and we say, is 3 less than 3? Well, that's false, right? So we're going to exit the loop and we're not going to continue. That's the sequence. So how you set this up is going to depend on, exactly what you need. How many times do you need it to go? And then you can decide what these, upper and lower limits are going to be. Where does it start? Where does it end? And how many am I incrementing by? Because you may not always increment by one. And I'll do examples of that. So this idea of keeping your code dry, don't repeat yourself is the idea here. And it's kind of a common expression, and it just basically says we don't need to have this code console log 1, console log 2, et cetera, et cetera. We don't need to do that over and over again when we can just write one line of code and use a loop to repeat it. So it's a great, concise way of doing your code. Okay. So I want to do a couple examples of really basic for loops where we're just kind of like, printing out a sequence of numbers, right? So let's come over here. We're going to set up a loop that prints the numbers 5 to 10. And we're just going to print them one at a time, one on each line, because it'll execute one line at a time. Okay, so I'm going to start by using the keyword for, have my parentheses, and then use the keyword let to create this local variable here. And I'm going to set it from to start at 5. I want to print the numbers 5 through 10. And then I could say, okay, how long should this loop keep executing? We want to execute as long as we are below or equal to 10. Now, the other way you could set this up is I is less than 11, right? So it would include 10, but not include 11. So it's kind of up to you how you decide to do that. It can be done either way. And then I want to do it every single number, 5 through 10. So I'm just going to increment by 1 each time. And then I will just console.log I. And let's run this. I need to get into my chapter 9 folder. So let me do that. All right, I will node loops. And we've got some titles in here. So there we go. All right, so we see 5, 6, 7, 8, 9, 10. Yeah, we're going to have a lot of stuff come out in the terminal by the time we're done. So I've got titles for each section to make it easier to find what we're looking for. All right, 5, 6, 7, 8, 9, 10. Good. Okay. Now let's do the same thing, but this time we're just going to start with 0. So I'll set it to 0. Say I is equal to 0. I is less than or equal to 5. Now, yeah, I said do the same. What I really meant was just do 0 through 5, apparently, because that's what I've got in my solution. I'll have to fix the instructions on that. Okay. Oh, no. I'm sorry. I lost track of what I was doing. I do want to do the same thing. I want to print the numbers 5 through 10. So if I start at 0 and I want to print 5, then I'm not going to console log I, right? I'm going to console log I plus 5. And that means that I need to go until I is 5, but no greater than 5, because the highest number then will be 5 plus 5, which is 10. So let's run that. All right, there we go. So we have 5 through 10 again. And this time we started in a different range, but we accomplished the same thing by using I as something we can do math with. And you're going to find that you're going to need to do this sometimes where you use the iterator based on a certain range, but then you need to adjust the numbers. So you would just do it like that. You just, add or subtract or whatever you need to do. So there's some basic examples of just looping through a few times and getting, those things executed every single time. All right. So let's actually make this real. We're working with some data, right? Let's iterate over some strings and arrays. I'm going to start with this example of iterating over a string where we have every single character at a different index, right? So that loop variable, that can actually serve as your index for bracket notation when you're working through a collection of characters. So we would usually just initialize that to 0. If you want to start with the very first character, you're going to need that to be 0. So that's the first index, right? And so the loop condition then can just be set based on the length of the character of the string, because you want to go through every single one in this case. So in this example, I have the string black, let color equal black. What would I put here for my loop variable? I want to go through every single letter.
Let I equals 0.
Good, yeah, let I equal 0. And for the loop condition, what do you think I might use?
I is less than color.length.
Good, yeah. Because we remember that the length of a string or array is one greater than the last index, right? The last index is one less than the length, is another way to say that. So if we want to go up through the last index, we just have to make sure that I is less than that, but never the length, because that would be one too far. So this is a very typical way to do this, to just use one less than the length. Okay, and then for my update expression. Right here.
Got an I plus plus.
I plus plus. We want to do every single letter, right? So what would I log now that I have this? And if I want to use I to help me identify one character at a time.
Color with the index of I. Color with the index of I.
Color and index I. Yeah, exactly. So this is how it works when you want to go through a whole, a string or an array. You can use this as your index and just access the values of, whatever character is in that string or whatever element is in an array, and do them one at a time. And because I updates each time, you'll have the next index on the next loop. So when we do this, color at index 0 is going to be
B.
yeah. And then it's going to go to the next loop and do L, and so on and so forth, right? It's just going to keep updating I, and then we'll get a different character at each location within the string using that as an index. Okay. So let's do some code here. We have a string, OB greeting, and it says hello there. And so we're going to display each of those letters on a separate line. So I'm just going to set I at 0, so I can start with the very first index. I will go all the way down to the length. And then I'll increment by all the way up to the length, I should have said, and then increment by 1 each time. And I'm just going to say, it's funny, I don't know why this says OB greeting and not OB1 greeting, because that's what it is in my solution, but whatever. Okay. Okay, so yes, we'll do this one at a time and just always grab the character that's at that index as we go through. So I'll come down here and run it. I'm going to need to pull this up. There we go. Hello there. We even have the space, right? Because that's a legitimate character at a certain index. So we see it go all the way through one at a time. Okay, let's do strings in reverse. It is possible to actually loop in reverse, because you can imagine we have incrementing, we also have decrementing. So one way to do it would be to do it that way with decrementing. So we could actually say, let's just set I equal to the very last index. And of course, we can use the length to calculate that, because we know the length is always one greater than the last index. And then the loop condition should be set to allow the execution as long as I is 0 or greater. So help me out here. Yeah, update expression will decrement instead of incrementing. So what should I put here to set the loop variable?
What was that? I. Set I equal to the length of the array minus 1.
Yes. So I'll use the keyword let to declare it. I create I as a variable here, and I set it equal to array.length minus 1. Good. And so then what about the loop condition? What do I want to put here to tell it how long to keep looping?
I greater than 0.
Yeah, I is greater than or equal to 0. We want it to include equal if we want to get that very first character, right? So in this case, we need to go all the way down to 0, inclusive. Okay, and then the update expression would be
Is it? Got I minus minus.
I minus minus, which is a little bit off center there. Okay, yes. And then when we do that, we will just console log array at index I, right? This is the idea. It's just this time we're going to start at the end and work our way down. So if I have an array that is 12 high and true, what am I going to get when I start off with length minus 1? That's going to be array at index what?
2.
Yeah, array at index 2, and I'm going to see what?
True.
True. Good. Yeah, and now it's going to go to array at index 1. It's going backwards. And then we would see high, right? And then it gets to array at index 0, and we see 12. And then because 0 is now, evaluated here, as long as it's greater than, if it tries to decrement, it's going to go to -1, and then it's going to evaluate this and say, oh, we're done. I'm not going to loop anymore. So that's it. We get true, high, and 12. Okay. I've got an example of this, pretty sure. Okay, we are going to iterate over this array in reverse and print each element. So we're going to do the same thing we just did. I'm going to say let I equal to, good heavens, having a little trouble here with my keyboard. There we go. Is equal to Akbar quote dot length -1. And now I will start with I at that value, but then go down until it is equal to 0, but no further. And then, of course, I minus minus. And now I'll just print Akbar quote at index I, and we should see things in reverse. Okay. It's a trap. Okay, so there we go. We're seeing that the expression is forward, but it's because the elements were backwards to begin with, right? So there we go. That's how we do that. What if we wanted to increment with something other than 1? Because I++ is always going to just do it by 1. I minus minus is always going to decrement by 1. We can actually choose anything we want. So we can use a different operator to make that possible, different shorthand. So let's say in this example, I've got these letters, right? And I would like to loop through every 3. Wait, hold on. Is that right? Yes, every 3. And I want to start with the 3rd letter, this H right here. How would I set it up to at least set the initial value of I to what I want?
We got let I equal 2.
Yeah, that's where we want to start. So we make I 2. So we can use that index first. Okay, then I want to go through the entire string. So I can just say, let's just do the whole thing. I is less than letters dot length. That's fine. But how do I tell it to update? If I want to do every 3 letters, what would I do?
What was that? I plus 3?
Close.
I equals I plus 3, or
Yes. Well, so the shorthand is this compound assignment operator, right? I plus equals 3. So it just says take the current value of I and increase it by 3 and then update I to hold that value. So I is no longer 2. On the next loop, it'll be 5, right? So let's see. Then we would just console log letters at index I. That's all we want. We just want the character at that index. So this part is pretty straightforward. This is what you have to think about. Where do you want to start? And are you going through the whole thing? And how often do you want it to stop and get the value? So we would say just do it every 3 by updating it by 3 each time. So we start with letters at index 2 and we get the capital H, right? And then the next one, letters at index 5. And we see that capital E, right? And then we just keep going. 8 plus 3 is 8. So we see L plus 3 is 11. We see another L plus 3 is 14. And we see that capital O. Okay, so if this is index 14, we have 15 and 16 here, and the length is 17. So you might have been thinking, well, what happens if we get to, here? I mean, this expression is always just going to be evaluated. Is it true or is it false? So if I gets to the point where it's at 14 and it says, okay, let's add 3 more and it's 17 and it evaluates this expression, the length is 17. So if we try to do I is less than the length, this is going to be false. And that's all that matters, is that you just make sure you don't go any longer than the length because there's no characters there. Yeah, so this works. All right. Let's do another example. We're going to print every other word in this array. We're going to start with index 0, and then we're going to do it again and change where we start to index 1. So I'll say let I equal 0, and I'm going to say go all the way to quote dot length, but I want, I need to say let I equal 0. I is less than quote dot length, and I needs to increment by 2. And I have an error here, in case you guys didn't catch that. This should have been 4. Okay, that's why VS Code was yelling at me with little red squiggly lines. Okay, so I can just log what I want to see, quote at index I, whatever word is there. But the key here is that I'm starting at 0, but I'm going every other word. So I plus equals 2. So let's run it. And we see I just as soon kiss a Wookiee. What if we change it and we actually say, okay, I want to see the other ones. I want to go every other word, but I want to start at 1 this time. We can do that. And now it says, I have a bad feeling about this. Okay. So that's how that works. And these, I realize these are very silly examples, but we're getting the concepts across, right? That's what's important. Okay. All right, now let's talk about using conditionals within loops, because this is going to be a very common practice. It is very common that if the reason you're going through a loop is because you want to evaluate some sort of logic, so we can totally do that. We can have an if statement inside a loop so that every single time it evaluates it. So not every loop has to do the same thing. So we can determine, when code is executed, or maybe some of the code gets executed and some of it doesn't, depending on what you're looking for. In this case, we're just going to say the entire code body, we want it to be conditional. We're just going to make it real simple. So the idea here is that we are only going to loop through and print the numbers that are evenly divisible by 5. So I'm going through the entire thing. I've got a classic for loop with starting at 0, going through, but not including the length, and incrementing by 1. So I'm going to look at every single character, every single element in this array. So how would I set up this condition to make sure I'm only printing the ones that are evenly divisible by 5?
If I mod 5. We've got if I mod 5 is equal to 0.
Okay, so yeah, nums at index I will go to the element in that array and say mod 5. And if that is strictly equal to 0, then we definitely have a number that's evenly divisible. So then we can just console log. Yeah, sorry. I apparently didn't want to do just that number. I wanted to do that number divided by 5 so we can see the outcome. So we want to do each one divide them all by 5, but only if they're evenly divisible. I really should put notes in my slides so that I know where I'm going with this. Okay. So I is equal to 0 to begin with, right? So what's going to happen when I is equal to 0? What will we see in the console?
What was that? When I equals 0 is 3?
Yeah, we're going to see 3 because it's going to include it and say 15 divided by 3 is 15 divided by 5 is 3. What happens when I is equal to 1?
What was that? So we're guessing 0?
All right, so let's think about this for just a second. We have a single if statement in here, and what things that we learned about conditionals is that the code inside that body of that conditional statement executes only if this condition is true, right? So if we have a loop and the only code in here is this conditional, then that means this line right here, this console.log, isn't even going to execute unless this is true, right? So it would actually just skip it. It'll go through the loop and there will be nothing to execute. So you're not, I mean, it'll execute the conditional in terms of evaluating this, but then it does not execute this. And that's the only code we have inside the loop. So that means nothing's going to happen. We're going to see no output. And so for I equals 2, the same thing happens, right? We skip it. We're not going to see anything. But then when I equals 3, we have 95. So then it says, okay, let's evaluate that. 95 mod 5 is 0. So we're going to see 19. And then of course, when I is 3, 48 is not divisible by 5 evenly. So it would just bypass that console log altogether. Okay, so that's how this works. This is the concept. You can have code that you want to only execute under certain conditions so that as it's looping through, some of them will hit and it'll do something for you, and other ones, nothing happens if it's all conditional and it's false. All right. Let's do an example. We have a string here now instead of an array. It's the forest of Endor, and there are Ewoks hiding in the trees, and we can't really make them out, so we have to go find them. And so we're going to do a loop so we can go through this a little bit at a time. And there's going to be an additional challenge here because we're looking for a substring that's going to be Ewok, right? So I'm going to set it up to start at 0. But I need to be a little careful with my condition here because I don't want to go all the way to the end, or it won't be able to evaluate a substring if we get to some of these last characters because there aren't any additional characters to look at. So I'm going to actually do it to indoor forest.length -3 so that I can make sure the last one I do is the fourth to last character. And then I'll increment by 1. Okay. So the idea here is that we only want to print that we found an Ewok if we did in fact find an Ewok. So I can have some sort of condition here to evaluate that, and then we can just say, console log. I'm going to use a template literal here so I can throw some JavaScript in there and say I found an Ewok at index, and we'll just say I, whatever the index is, and throw that in the sentence. Okay, and I apparently got rid of my brace. There we go. Nope. I'm having trouble with the fine motor skills today. Okay, so now what we might evaluate here, we need to take a substring. Does anybody remember what the string method is that we would use for that? No guesses? Okay, we're going to use slice because we can take a substring. We can say start with index I and give me 4 characters. So I'm going to go to I plus 4. And we're going to check and see if that's equal to Ewok. So if I have to spell it right. Okay, there we go. And if it is equal, if that substring at, from that index to, for those 4 characters, if that's Ewok, then we're going to print this. Otherwise, if this entire thing evaluates the false because we don't find exactly Ewok as that substring, it'll skip this line of code on line 60. So we should only see console logs where it actually finds them. Let's run it. All right, I found an Ewok at index 4. I found an Ewok at index 16, and then again at 31, and again at 45. There were only 4 of them hiding in there, but we found them all by going through them very methodically and just evaluating each substring to see if it matched. So these kinds of operations are the kinds of things that will allow you to do interesting things with, with strings and arrays when you might be looking for something very specific. So you just have to think about first how to navigate, how to actually set up the loop so that you go through from the start to finish that you really need to. And then if you have, condition that you, think about what that condition is going to be so that your code only executes when you really want it to. That's the idea here. Okay. I want to do the accumulator pattern. And before we take our break, we'll do a few of those. So, but first, let me just stop here and see if there's any questions on anything I've talked about so far, because I know we're doing a lot of, tiny little concepts again today.
When you run loops and you bring things, does it have to be on the subsequent line if you all go in the same line?
When you run loops and you print things, do they have to all be on the next subsequent line, or can it all be on the same line?
If you do it like this with a separate console log statement executed every single time, they're going to be on separate lines. The way to prevent that would be string building, and that is one of the accumulator pattern methods that I'm about to demonstrate for you. So you're just thinking ahead. Any other questions?
Not looking.
Subtract 3 again from the line. I'm just trying to understand that. And go 4, so subtract it.
Yeah.
Why did we do that?
Why did we subtract 3 from the length in the loop condition?
Yeah, because if we're evaluating, like first it evaluates, at index 0, EOWK, right? Then when it increases by 1, it's evaluating this OWKE, and it just keeps going like that and taking slices at every single one. So when we get to the end, the last substring we really need to evaluate is just the KOWK there, right? And that K, which it's based on the starting index being, this one right here, that's at length -4. So that's the very last one that we want to do. Therefore, we want to say it should only execute if I is still less than, length -3. Because length -4 is the last one we want. Does that help?
Yeah.
Okay. Yeah. Okay. All right. Any last questions? We're going to do accumulator pattern. Nope, we're good. Okay. So let's talk about this. The accumulator pattern, the idea here is that you are tracking some sort of value while you're looping, and you're maybe, changing that value or adding to that value. And that's what the accumulation idea is, that you're, updating and adding to something. So the first obvious example is if you want to add up a bunch of numbers, right? Let's say we have a series of numbers in an array. We can declare a variable to hold that sum inside our loop. No, outside the loop. That's important. Outside the loop, and initialize it to 0. So we have somewhere to start. And then we can loop over the array numbers and just keep adding them one at a time to that variable so that it keeps growing every time we go through. And then when we're finally done and the loop stops executing, after that, we should have, the final value, right? And then we could just print that and see what it is. So that's what's happening here. So let's say I've got, nums is 5, 2, and 9, and the sum is set to 0, so we can just start there. Then we loop through the entire array from 0 to the last index by doing, less than the length. What would I do here to add up the sum? Sum plus equals.
Num bracket I.
Nums at index I, good. Because we want to just access the element at that index as we're looping through. So when we get done, we should have the sum. So sum starts out as 0. On the next iteration, we have sum plus nums at index 0. So what would be the value then?
5.
Yep. And then it increments. And so we say, okay, let's take sum as it now exists and add nums at index 1. So now we have
7.
right? And then it goes to nums at index 2. And we add that on. And we have 16, right? So then if we go and we console log 16 or console log sum, it's going to be 16 now. So you can see that we're updating this value of sum every single time by continually just, adding on the value that's at the next index in that array. That's the process that the loop is going through. It's just updating, updating, updating until it gets to the end. Okay. So I'm going to count up the number of moons. Now this is these are not numbers, right? But it's still this accumulator pattern. I want to first say I need a variable to keep track of the number of moons that I'm finding. So I'm going to say num moons equals 0. That's my base value. And then I'll set up the loop and say, for start at I equals 0, go as long as moons.length, but just below that, and then we'll increment by 1. And now we have some conditional logic because we only want, I need to fix this, don't I? Okay, there we go. We only want to add to num moons if we actually find a moon. So what we're going to do is we're going to have an if-else situation so we can actually see something in the console when it's not true. So I'll say, if, and we'll have a condition. If it's true, then we could say, I found a moon. Okay. And then we could say else, and we could print something like, that's no moon. That's no moon. Okay. But let's talk about the condition first. If it's true, that means we have to look at moons at index I to evaluate it. We're doing these one at a time, right? And so we're saying if it's true, that means we found just a moon, right? So it must be equal to the string moon. But and otherwise we're going to say that's no moon. What's missing here? What am I not doing that was my ultimate goal? Because what I'm trying to do here is say there are a total of num moons. So what do I still need to do?
Add up how many moons you found.
Yeah, I need to increase the number of moons every time I find one, right? There's a couple different ways you can do that. You might say, oh, okay, I'm just going to use that compound assignment operator. What you'll find most professional devs will do is just use the incrementing shorthand, because if you're only increasing it by 1 in this instance, you can just do that. So you could do either one, or you could say num moons plus equals 1. Either way, it's just going to increase it by 1 every single time it finds one. But if it doesn't increase anything. So this is where it becomes very important for you to decide where do you put your code. You'll also notice now that we're starting to get into different types of structures and mechanisms, indenting continues to be very important here, right? The for loop needs to have everything indented so you can tell what's inside its code body as you're reading through your code. Now we have if statements in here. We have to indent that further so it becomes very obvious that these 2 lines of code belong only when it's true, and this line of code is only when it's false. I will demonstrate this for you by putting everything back against that wall. That's a lot harder to read, right? When you don't have any indenting. So if you're not yet being real particular about your indenting, you want to get in the habit of that for your own sake. It'll help you find where you're missing things. And also for the sake of anyone else who's reading your code, which in a professional setting is very important. Okay, so, but I digress. The point here, of course, ultimately conceptually is that we want to make sure to increase it only when we actually find a moon, otherwise we don't. So we should find at the end, if we just look at this, we can tell there's only 3 moons. So we should find that it's only actually increased it 3 times, because when it gets to the Death Star, that's no moon. Okay, let's do it. There we go. I found a moon. I found a moon. That's no moon. I found a moon. Okay. There are a total of 3 moons. All right. So that's one way to use this accumulator pattern, is to add something up. And then in this case, we actually did it conditionally. We only increased it under certain conditions. Okay. Now let's talk about string building. So this is exactly where it's this situation where you don't want things to print on individual lines. You would like to create a string that you can just print all at once. We can do that with the accumulator pattern. So you declare a variable to hold the new string, and typically you're just going to initialize it to an empty string, unless you have something you need to put at the front regardless. And then you just loop over the string or array and add to that string. So we can start here. I'm going to go back. Okay. We can start with this. This was the thing that was on one of those first slides, right? Where we had this mix of letters and numbers. And we said, if we want it to only have the letters at the end, then we need to evaluate this on whether they're actually alpha characters or numeric characters, right? So I'm going to start by saying, I want the correct text. I'm going to build it 1 character at a time. I'm going to set it equal to an empty string. So now I have a string. JavaScript recognizes this as a string that I can concatenate with. And we'll loop through the entire string from 0 all the way up to, but just less than the length. So we get to that last index, this last index, the exclamation point. And we say we're going to increment by 1, so we can look at each one individually. What we really want here is not just alpha, we also want special characters. What we don't want are numbers. So here's the tricky part. There's going to be some logic, and I'm just going to give it to you. But there's 2 things we want to evaluate here. So we actually are going to need one of those. What was that? Have balloons. Okay. I wasn't even touching my keyboard. I have no where that came from. Okay. We can have 2 different things we're going to try to do, and we're going to use that logical operator or. We're going to say if we look at that character and try to evaluate it as a number, but it's not a number, then we want to add to it here. Also, if it's just a blank, because we want to include the blank, but if we try to evaluate that with like is not a number, it's not going to work the way we expect. So we actually have to have 2 different things here. So there's a little function you can use to test if something is not a number or not. So I'm going to say, if this is not a number, and I take the number function and pass in text at index I, let's evaluate the character, try to convert it to a number, and see if it's not a number. If it's not a number, we'll add it to our string. Or if it's a space, we'll add it to our string. Okay, I know this is a little bit, we're doing a lot of things here all at once, but I would like to say, hint, hint, this kind of thing is going to be useful for you on future graded assignments. Maybe not right away, but you're going to have one later down the road in this unit where this kind of evaluation for validation is going to be important. So yeah, is not a number is a helpful little thing. So then we'll just do that, and we'll just say, okay, add that character then, right? Go to text at index I, the one we just evaluated. We're good to go. It's definitely not a number. So we'll add it. And then otherwise we don't need an else condition here because we just want it to skip it and not add anything if it's a number, right? So we go all the way through and we loop through and do that. So then when we get the correct text, we have letters only because it only added things that evaluated to not a number or were spaces, which we did have a space. All right, let's do an example of string building. A stormtrooper is chasing you and firing his E11 blaster rifle, which of course is not hitting you at all, but it makes a cool sound. So let's build the string pew, 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 and we're going to do it one pew at a time. So let's start with establishing an initial empty string, always necessary for string building. So we have somewhere to start. Okay. Now we'll go through and say, we just need to go through 3 times. So I'm going to start with I = 1 and say, as long as I is less than or equal to 3, we'll keep going and then increment 1 at a time. Okay. So the first thing I need to do is say 3 pews plus equal pews. So this plus equal is not just for numbers. You can actually use this in JavaScript for concatenating strings as well. And it treats it like concatenation. So you can just say, take the current value of 3 pews and just tack on another pews. And I didn't mean to put pew with an S, I meant to do pew. Okay. And the other thing we want to do, because if we run this right now, and so let's say I get done with this and I print 3 pews. Okay, we can see the final result and I can go ahead and run this. And we say, okay, pew, pew, pew. It's all one word. What if we wanted to put spaces in? But we don't want to put a space after the third one. We could introduce some logic in here inside of our loop and say, if I is less than 3, we're not quite to 3 just yet, then we also want to add conditionally a space. So these are some little tricks you can use when you're building strings to say, I always want to add something, and then maybe I also want to add something else by having a condition. So we're either going to get pew and space, or we're just going to get pew once I = 3. So we can do this, and I can certainly see the final result here. Pew, space, pew, space, pew. And you can't see it, but there really is no space after that. If we were to change it and do it as like something like a exclamation point space, it might be a little more obvious. Yeah, pew, pew, but then we don't have the exclamation point. Okay, that would be more obvious. We can also, if you want to see what it looks like on every single loop, and this is going to be a really valuable tool for you as you're learning how to do this, stick a console log in here, even if it's temporary. And just say, I want to see the value of 3 pews on each loop after I, evaluate this. So can you just show it to me every single time, right? And so if we run that, really need to start using my Command J to do this. Okay. I see pew, and then I see pew, pew, and then I see pew, pew, pew. And then of course, because we had console logged it after the loop, we're seeing it again. So that could just be something temporary you do just to say, I just need to see what it looks like on every loop. And that's a very valid developmental tool for you. All right. The third method of accumulation would be to filter an array. You have an array and you want to create a new array that contains some of the elements, but not all of the elements based on a certain condition. So you just create a new array instead of modifying the existing one. And you say, okay, I need a variable to do that. I'm going to store an empty array initially, and then I'll add things to it as I go through, but only under certain conditions. So if we have the words July, August, and September, and for whatever reason, we've just decided we only want the words that are longer than 5 characters long. So we're going to evaluate these one at a time and decide if they're greater than 5 characters long, we're going to stick it in here. If not, we won't. So we'll loop through the entire array. This is a normal, just start at the beginning and go all the way through the loop and evaluate each element one at a time. And then we'll say, okay, if the word that I'm looking at, if the length of that word is greater than 5, then I want to do something. How would I say that? How would I access the length of that word?
Words that index I.
Words in index I.
Dot length. Yeah, this is the tricky thing. When you're first learning to do this, you have to think in terms of accessing the element itself, which is words at index I. But if we're actually evaluating the string, now we have to think, oh yeah, this entire thing, words at index I, represents a string in this case. And I have a method I can use to evaluate its length. So you can just tack that on. Getting used to this sort of thing is going to be really important. In fact, you're going to practice it in your studio today too. That, you may have certain methods that you want to apply to an element. And you need to remember that the element is represented by words at index I, with whatever the value of I is. And then that string is where you check the length and evaluate it. Okay. And then, of course, if it is, then I could put it in this array. How would I do that? Anybody remember?
Words dot push.
Well, if I push it into the original array, then I'm just going to have, this array is going to get longer and this array is never going to change. So consider the fact that this is an accumulator pattern where we're starting with something that's empty and we are adding to it, right? So I actually want to push into longer than 5. I have a new array and I want to start building stuff. And that's the array ultimately that I want to take a look at, that I want to have values in. So I would push that element, words at index I, into the new array longer than 5. And then when we get done looping, and we've done that for every single element, if it met that condition, we can console log it. And what am I going to expect to see in longer than 5?
August and September.
Yeah, exactly. Because it evaluated it for July and it wasn't true. So it just skipped that. It didn't push it in. Okay, so that's how it works with filtering an array. You create a new array and just selectively add things to it. We'll do a real quick example and then we're going to take a break. Okay, so I have all of these names of different people and places from Star Wars, and we're going to create a new array that says only A names. Only A names. We only want to add names that begin with A. So I'll loop through the original array. So I need to base this loop on the original array. And then take a look at the element that I'm looking at, which is names at index I. So maybe I'm looking at Alderaan, right? And I'm going to say, I want to evaluate just that first letter, right? So I'm going to check the first character at index 0 of that string. And this is the string, names at index I. So again, just keep in mind that, when you tack this on, you're tacking it on to a string because names at index I represents that string. And now we're saying, look at that first character and check and see if it's a capital A. And if it is, we're going to go to our new array, only A names, and push names at index I, the whole element, the entire word. And then when we get done, we can check our final value of only A names. And we see Alderaan, Andor, Armorer, Ahsoka, Akbar, and Amidala, but not any of the other things that were in that original array because their very first character was not A. Okay. Any last questions before we take a break?
So regarding the validation, why does when you're comparing to non-numbers, why is that the validation false?
Say that once more.
When you're comparing not a number, it's false. Why is that?
when you're comparing not a number to not a number, what does that evaluate to false? Restricted quality?
You talking about the one that was on the slide?
Yeah, like when you have use is not a number function instead of.
Yeah.
Or not a number, not a number.
Yeah, so the way this works is I'm taking the character and I'm trying to convert it to a number with number. So this entire thing from here to here then is either a number or it's not a number at that point. Because we remember that number will convert it to not a number if it's not. So then I'm asking, is that value not a number? And if it is, it'll be true. And that was what I was looking for is it true that that's not a number? Because if it's not, I want it. I want the letters. Yeah, I know. It's a lot of like the negatives and positives of that are a little bit to think through, and that's okay. You're going to get better at this, I promise, because you'll get used to thinking through all of this a little more easily. All right, we have to take a break because we only have half an hour to do a whole lot. So let's go ahead and take a 5-minute break. And so we want to talk first about the structure of a while loop because it is a little bit different than a for loop. You want to use the keyword while instead of for, which I think is fairly self-explanatory. But then the loop condition is set up a little differently. You need those variables. If you have variables that you're depending on, they have to already exist at that point. You don't declare them inside that inside the parentheses there. So but it will indicate whether the loop should continue running, just like it does for a for loop. So you just need to make sure that logic, that Boolean expression, is going to definitely evaluate to true as long as you need it to run, but evaluate to false when you want it to stop and not run. The loop body, just like a for loop, is, enclosed with those curly braces, and any code you put inside there will execute, unless you have it wrapped in a conditional, of course, but it'll execute each time. So if you need to make some sort of an update to something that you're depending on, you need to do it, like actually do it inside there before you, finish that iteration. So in this example, I'm actually doing something like this is where I'm like converting a for loop to a while loop, just so you can see the differences, right? Let's say I had a for loop that was going to go from 3 to 5. That's all I really want. And so I could say, okay, I need to create I then outside the while loop so it exists. And then I can evaluate it as the loop condition. As long as I is less than 6, keep looping. I want you to print I, and then I need to not forget to update I. So I do still have these 3 things happening in this case. They're just in different places when you have a while loop. Now, if I was doing this sort of thing, I probably would use a for loop because I know exactly where I want to stop and start, but I just want to help you transition your thinking. So if I took a for loop and converted it to a while loop, this is what it looks like. So again, I have a keyword while, and then I have the loop variable I that I'm depending on for the loop condition. And then I need to make sure that, I put anything I want to execute on the loop inside that body, and that part of that is updating that expression since I depend on it. Otherwise, we end up with an infinite loop. It will just never stop if you don't update it. So now I go through and while I equals 3, it's going to execute and it will console log 3. And then it increments that to 4 and evaluates it again, and it prints 4. It does it again and it prints 5. But then when it increments it to 6 at the end here, it evaluates that and no longer meets the condition. So it just moves on to whatever's after the while loop in your code. So let's do a real quick example of this. Let's say that Han Solo's keeping track of the distance while he's making the Kessel Run, and he's about halfway through. We're going to let him count down. So we're going to start with a total distance of 12 parsecs and let the current distance be 6. This is where we are right now as we're halfway through. So we're going to say while the current distance is still less than the total distance, we have something we want to print. We want to say, for the sake of time, I'm going to paste this in. All right, still speeding dangerously close to the black hole cluster, total distance minus current distance, parsecs to go. So I'm just subtracting them to say how far we still have to go. And then I need to make sure that I increment current distance, because otherwise it's just going to be the same, and it's just loop and loop and loop and never stop. And now I can just say, we did it, you know, after we're done. Okay, so I'm going to pull this up and run it. Okay, still speeding dangerously close to the black hole cluster, 6 parsecs to go. And then we see 5 and 4 and 3 and 2 and 1 because of that subtraction I was doing. And you can tell that, you know, current distance was continuing to increment, which was making this number smaller when we subtract it from the total. So that's the basic, you know, syntax for a for loop. That's how we make it work. So why would you choose a while loop? Like under what circumstances would it be better to use a while loop than a for loop? There are a number of scenarios that would be common, but the main condition, the main reason would be you just don't know how many times you need to go. Okay, so if you know how many times you can go, just use a for loop, because you can be very specific about the beginning and the end. I want to loop exactly this number of times, and you can calculate this from the way I'm setting this up. But if you don't know, then you need a while loop. So common scenarios would be like you're iterating over an array or string, but only until something's false. You don't necessarily intend to go all the way to the end of the string or to all the way to the end of the array, but you're not really sure when you're going to hit the condition that would cause you to stop. Maybe you're modifying some sort of value over and over again, and you know, until a certain condition is met. Maybe you're validating user input, you know, because users will give you things that you can't use and your code would break. And so it's very important for you to handle that and prevent your code from breaking and the program from just stopping with an error. So validating is a huge use of while, and you're going to get lots of practice with that in a lot of different places, but in your graded assignments for sure. Starting, I don't think you have it in grade assignment 1, but you'll want it for grade assignment 2. Okay, so let nums, we have an array of numbers here. We're gonna say that I needs to start at 0 because we're actually going to use it as an index in this case. We want to look at each element one at a time. So in order to facilitate looking at them one at a time, we do need an I. So I'm just going to say let I equal 0. But I also want to track big number. I want to say if I come across a number that's greater than 50, I'm going to consider that a big number and say this array has a big number. So I can initialize that to false, right? Because we don't know if we have a big number until we find one. So it needs to be false until we change it to true. So I'm going to say while we don't have a big number, while not has a big number, in other words, as long as this is if has big number is false, then this changes it to true, right? So as long as that's true, that this number is still false. And while we still are less than the length of the array, because we don't want to keep going. If we never find one, it would just keep going. And we don't have any elements after that, right? So we actually we have 2 different conditions that could stop this loop. And that would be if we get to the end and we haven't found it, or if we change this to true, and so not true would be false. So if we are going to evaluate this, if nums at index I is greater than 50, then we can change has big num to true and say we found one, right? But we have to remember that we're working through an array and we're looking at things element by element. So we also have to increase this index so that we're looking at a new element every time we go through. But we won't necessarily go all the way to the end. If we find a big number, then that's when this first condition will actually will be false, and therefore the entire thing is false and the while loop will stop. Okay. So let's see. Do I want yes. So we're going to search for something here. We're going to be looking for a specific string and we're not sure if it's in there. We're just going to go look element by element and see if we can find it. So we've got the Mandalorian's got a bunch of bounties, and we're gonna look and see if we can find the child. So I'm going through an array, so I definitely need something to use as an index. So I'm just going to say let I equal 0. And then I'm going to have a Boolean so we can tell if we found the child or not. Has found the child, and I'm going to set that to false. So far, I haven't found the child. We only want to stop the loop when the child is found or if the iteration through the array is done, just like I was explaining on the slide, because maybe we don't find the child. So we just have to make sure we stop when the loop stops. So both of those things still have to be true, that either we haven't found it or we're not at the end yet in order for the while loop to continue. So either not has found the child, and so as long as I is still less than bounties.length and we have not yet found the child, we're gonna execute the code inside this while loop. By the way, this is a reason why naming your Booleans, it can be really helpful to name them this way, because it's very nice when you have this type of expression to be able to say, well, you know, not has found the child or has not found the child. Because it just reads easy. It makes it easier for you to think about what it means. Okay, so I can say, let's go through and just check in the array. We're going to check each index one at a time. We'll use I to do that and look for child. And if we find that child, then we will change has found the child to true. We also need to make sure that inside the loop, but after the condition, we increase I so that we continue to look through new elements each time. Otherwise, we'll just stay on the very first one and never move forward. So two things. We're changing this potential thing that could impact the condition here, and we're also possibly changing this one that could impact the condition here. So I can run this, and if I run it right now, we're not going to see any sort of output. So we need to put something in here that will let us know what's happening. I'm going to put a couple of things that are going to help us really see what's happening here. I'm going to say searching at index I. So we can see the value of I on each iteration. And then I'm also going to put a console log inside here if we do in fact find the child. Say, I found the child. Okay. Now let's run it. Since we have some console logs in here, it'll kind of give us a picture of what's happening behind the scenes. Okay, searching at index 0, searching at index 1, searching at index 2. And then it says, I found the child. And you'll notice that even though there are additional elements in here, we could have, kept going and gone all the way through the end. But because we changed has found the child to true, this loop will no longer execute because this now evaluates to false. So that's how you control that. You're going to stop on one of two conditions. Yeah, so we went ahead and found it, and therefore this evaluates the false together with the not, and it exits. All right. Let's talk about user input validation. Like I said, a very, very common application for this. The general basic steps that you want for this would be you're asking user for input, right? You're storing it in a variable. Well, then you can check that value with a while loop if it's valid or not, if it's what you're looking for. Maybe you're looking for a number. Maybe you need to make sure it's not a number and it's something that is a valid string of some kind, or you're just checking for a specific value of a string. Some of the common scenarios for numbers would be, you can't convert it to the data type needed. The number is out of range for what you need. Like maybe you are only looking for 4 different specific responses. You've told them, can you give me option A, B, C, or D? And if it's anything other than that, it doesn't work. Or 1, 2, 3. And if they give a number, lower or higher than that, it's out of range. Also remember, an empty string is faulty. So it can help us evaluate. Maybe they just hit enter and didn't give us anything at all. And so we have an empty string. So we can do some input. Let's say we ask for a number from 1 to 9. And so we can validate for the type and the range here. First, we can say if that number is less than 1, then we need to ask again. If it's greater than 9, we need to ask again. What if it's not a number at all? Then we need to say, is it not a number? And if that's true, we would want to ask again. Now, if I feel like I need to do this over again. If I was coding this, actually, I would put this one first. First, check and see if it's even a valid number, and then check the range. So I probably would make sure, because it's going to evaluate these from left to right. I would probably put this one first. So I'll fix that for the future. But basically, if they do any of these things, it's not a number we can use. It has to be a valid number, 1 to 9. Then we can ask them again and just reassign that variable. We were, storing the input as a number from in this variable num. So we can say, okay, let's just reassign it. We'll take their input, convert it to a number, and store it in num again. And we just keep doing that until finally none of these things are a problem. And then it moves on. So if I were to, if I was the user and I put in an empty string, what would happen? It would evaluate it as, num is less than 1, and that would be true, actually, right? Because it evaluates an empty string as 0. So what if the number is 11? It's going to hit the next condition, num is greater than 9, and that's going to be true, right? And we're using OR operators here, which means any one of these can be true and it'll trigger it. If the num was ABC, well, that triggers is not a number, right? And so these are all cases where it's going to trigger one of these 3 conditions and be true, so we're going to keep asking. But then they finally give us a 4. And so it's false, false, and false, which means the while loop will stop asking and our code can move on. We have something we can work with now. That's validation. That's how you make sure your user input works for what you need for your program and won't break your program or cause some sort of unexpected result otherwise. Okay, so another common scenario is with strings. If you have like an empty string, but you're expecting a string, so you're not even evaluating is it a number or not. There's ways that you can do that. So let's say we're asking for if they're ready to begin. Are you ready to begin? Yes or no? We can first, notice I have these in all caps just to make them stand out. But what if they don't type it in all caps? I need to make it case insensitive first. So I'm just going to make sure that whatever they put in, I put it to uppercase, and now I can evaluate it against uppercase yes and no. So I'll say, okay, it's got to be either yes or no. So if they give me something other than yes, or they give me something other than no, I want to ask them again. So I'll say while begin is not equal to capital YES, or, and begin is not equal to capital no. So if both of those things are true, it's not yes and it's not no, then we want to ask them again. Invalid input, yes or no. And then make sure we also are continuing to deal with that case, right? So I'm chaining on that method to uppercase here to make sure whatever they give me, the input.question response is actually made uppercase before I store it and begin. So this is a way you can do that all in one line. And then it'll just keep evaluating until they actually give us something that when we make it uppercase converts to exactly yes or no. So begin, let's say they hit enter before they realize that they were supposed to type something in. Well, an empty string is definitely not yes and it's not no. So we get true. So the while loop continues. We say, heck yeah, that's actually not valid input, even though it's clearly an affirmative response. So it's true, so it keeps asking. If we get begin equals yes, false. So it'll stop asking and move on. If we get begin equals lowercase no, no problem. We made it uppercase, and so it's going to be false. It's going to say, okay, we're good, and it'll move on. So this is how that works for strings. So let's go over and just do an example of validation here. Luke, Han, and Chewbacca are trying to rescue Leia, who's being held in cell number 2187. So if they're within the 2100 to 2200 blocks, we want to tell them they're on the right track. Otherwise, we'll tell them to keep searching. So I can say, let's have something to store the block number and ask them, hey, where are you? What's the block number? What cell block are you at now? Okay. And then as long as they give us a number that's less than 2100, that was supposed to be a less than sign. There we go. Or they give us a block number that's greater than 2200. Then we need to say, we need to ask them again. And say, nope, keep searching. And then we'll let them tell us where they are again, and we can, keep evaluating that. But once they get to the point where they're really close by, we can just say, you're really close. Now find cell 2187. Okay. All right, so we can try this out. I've already got my my npm install taken care of here, so we should be able to use the readline sync library with no problem. Okay, what cell block are you at now? So I'll say, 2300. Nope, keep searching. And then I'll say, okay, I'm at 2320, or no, 22. What did I say the ranges were? Yeah, I'm at 2250. And it says, nope, keep searching. Well, then I get to 2190. You're really close. Now find 2187. Okay, so that's how that works. You can just keep asking until they arrive at what you're looking for, and then you can move on once those both evaluate to false. Okay. We might run a few minutes over here. We are going to run a few minutes over here, but we are going to just push the schedule a little bit. You'll still get your hour for lunch, so no worries there. Does anybody have any questions real quick before I move on to nested loops? We
Looks like
good?
we're good.
Okay. All right. Right. Infinite loops. I do want to talk about this first because this happens, especially, I mean, like with while loops, it's going to happen. It'll happen to you at least once. Okay. So an infinite loop never stops running because that condition that you set after the while keyword just never evaluates to false for some reason. It's very common to have that happen when you have things like mixing up the less than and greater than signs, or incrementing instead of decrementing, or vice versa. Forgetting to change a Boolean, forgetting to increment or decrement with an iterator that you actually need to, explicitly do that before you go around another time. Those are usually the culprits. So if I have for let I equal 25, I is greater than 0, I plus plus, console log I for some reason am just seeing I'm seeing nothing but numbers 25 and greater. Why is that? And it just never stops.
Supposed to.
Yeah,
Okay.
yeah, I actually heard that. Yeah, because it's supposed to decrement, right? Because we start with 25 and we're working our way down to 0. So these two are fine, the condition's fine. We're increasing I instead of decreasing it. So that'll cause an infinite loop. It just keeps going from 25 on up infinitely. Okay, this one I have let string equal, and I've got this big long thing with a couple of letters that have been doubled. So I'll say I'm looking for doubles, has double equals false until I find one. And so I start at index 1 so that I can compare it to the one before it, which is why I don't start at 0, because I'm about to refer to I minus 1. So I start at 1 so I can do that. And I say while not has double and I is less than the string length, I want to go ahead and just check, is the current character the same as the character just before it at I minus 1? And if so, we'll change has double to true. But for some reason, my loop just keeps going and going, and I don't know why. What am I forgetting?
Change my.
Is that to change I?
Yeah. I never changes, right? I was one and it just continues being one. So over and over again, it's comparing characters B and A and it never moves on. And it just keeps evaluating to true. So we just, both of these are true. So it just keeps going and going and going. You have to remember to do that to make it keep going. So that's a couple examples. Let's see, a real quick, I feel like I had an example for this. Okay, I'm just gonna move on. It's okay. You you can test this on your own and it will definitely, I mean, I probably could just change one of the ones we've already done. But that's okay. You get the idea, right? That it would just keep going, going, going. Let's talk about nested loops because you need to know how to do this for your studio today. It's important that we cover it. So a for loop inside a for loop, and if that's starting to blow your mind a little bit, that's normal. You are exactly where you're supposed to be because it's enough to understand how a loop works at this point, much less understand how nested loops work. But that's okay. We have one class to talk about loops and then we have to move on. So let's talk about it. It is customary to use that iterator I when you're going through a loop, right? But if you have two loops, what is customary is to use I for the outer loop and J for the inner loop. That's what most people will do. So we can set it up and then just use double bracket notation if we're working with like a multidimensional array or an array of strings that we're looking at it character by character. Those are both, times that you might need to do this. And so in this case, I've got an array of strings, and I really want to look at them character by character. So the first thing I have to do is go through the array and look at it word by word. But then when I get to each word, I'm going to loop through each character in the string. So I have to have nested loops for this. So we'll start by going through the array. That's the outer loop. And I'm going to say, let's create I. I is going to keep going as long as it's less than the length of the array so that we can look at each of these elements one by one. And then we'll increment by one, right? And then inside that, I'm going to create another loop just to go through the current word in the array. So I'll say let j equal 0. And how would I set my condition here in terms of array to tell it how long to go when it's going through the word?
Array at index I dot length.
Yeah, great. So this is where it's helpful to remember that you're actually evaluating just one word at this point, right? Which means you're going to array at index I and getting that word and then taking the length of that word so that you know how many characters to go through. And so it doesn't matter that these all are different lengths because every time it gets to this, it's just going to evaluate that word. And then when your I increments and it moves to a different word, it'll evaluate all of this based on the length of that word. So this is dynamic. It's, it changes. And so you can do array at index I dot length to go through character by character. So now, how would I say I'm looking for the letter A and I only want to print this if I find an A? What kind of condition could I write here? Does anybody have an idea how I would check for the letter A? Using both I and J. Nope. Okay, that's all right. So we first just keep in mind, we're always going from the outside in with double bracket notation, right? So first we're going to array at index I so we can access the word, but then we need to access the specific character. And that's where J comes in because we're going character by character with J. So we say array at index I at index J and compare that to the letter A. And if the current character we're looking at with index J of the word that we're looking at with index I in the array is the same as A, then we'll console log it and say, okay, the word array at index I has an A at index J. Okay. So this is what you have to wrap your head around, that you are doing two things at once. And on each iteration where I changes and you're looking at a word, then you're going to stop and do a little bit of multiple loops here, as long as you keep coming into characters for the length of that word. And then it moves on and goes to the next word using an increment of I. So you're always going to be able to evaluate every single character and every single word by using double bracket notation to access the word and then the character in whatever combination of I and J you have. Okay. So let's say that I was 2 and J was 3. What would I see? Yeah, I heard that. Yeah, great job. So beta has an A at index 3. That's exactly right. So that's how you have to think about this. That you're working your way from the outside in, and letting kind of two different processes happen on two different levels. So let's do a quick example of this, and then I will get you guys out of here for lunch. All right, so we have a multidimensional array here, right? We've got characters, and we have different groups of characters from different parts of a story. So each one of these is an array with strings. So we kind of have, if we want to loop through these and look at them string by string, then we're going to need to have nested loops so that we can first go through characters and then go through each of these individual arrays for those strings. So I'll set it up. Oh, I'm looking for Leia, by the way. So we actually need to look for Leia and set false. Now, you might say, if you're going to do it this way, why not use a while loop? That's a good question. There's another way that you can exit out of a loop early, even if it's a for loop. And I forgot to show you that slide. So let's talk about it. What if you wanted to exit out early? If you come across something and you say, oh, I actually don't need to keep going, even though I set up this for loop to go through to the end, I can use this break keyword and that will exit the loop. So in this example, I've got scrambled with all these different numbers, and I'm just saying, let's just go through one number character at a time, since it's a string, and see if we find a 4. So I'm just going to check scrambled at index I and say, hey, I found a 4. But let's say once I find it, I'm done. Then I can just use the break keyword and it will stop. So it goes through and evaluates them all one by one, and then it hits this 4 right here. And I'm not really interested in looking for the second 4. And this is kind of like what index of and includes do, by the way. They get to 1 and they just stop going through. So we exit early, we break. Okay. So that's what we're going to do. We're going to take that approach here. We're going to write 2 for loops nested so that we can look at each string in these nested arrays. But we're going to use a Boolean here to say whether or not we found Leia. And if we do find her, we'll just go ahead and break out of the loop. So let's set it up. So I'm going to have I is 0. And first I'm just going through characters, the outer array, right? So I'm going to say I'm going to go through as long as we are less than characters.length, we'll keep going and increment I with each new element that we have in the greater array. And then I'm going to set up a way to go through and look at a string at a time within each of those arrays. So we'll do let j equals 0 and say we need to go to characters at index I and look at that particular array at that's that element, and then check the length of that array and increment j each time in order to look at each string in the array. So then I could just look for Leia. I could say, okay, I'm at characters I, and I'm looking specifically at string j, and I want to see if that says Princess Leia. And if so, I'll say true, and I'll break out. so that we don't continue. Now this is all well and good. But the other thing to know is that this only breaks you out of the inner array. It doesn't actually, excuse me, the inner loop. It doesn't break you out of the outer loop. So you'd actually have then to say, if Leia has been found, we want to break out of this loop too. Just keep that in mind. In a situation like this, you'd have to break out of each one individually at different levels. So tuck that away if you ever decide to go this route. And then I could just, I can console log Leia found, and we'll just see what we ended up with. And that, will at least kind of tell us where we landed. So I can do that. Let's run it. Oh, okay. And we get true. So that's fine, but it doesn't really tell you a lot about what's happening here, right? You're like, all that happened behind the scenes, JavaScript took care of it, but I have no idea how it just processed through all of that. That's where you can put in console logs, even if they're temporary. You can put in some things to help you understand what's happening when. So I might say, selecting, oops, I forgot there we go. Selecting the group at index I. So I can see what group of characters am I evaluating at this point. Oh, for heaven's sake. There we go. And ooh, my allergies are starting to hit. Now that'll get us every time we loop through on I, that helps, right? So we can see how that works. And let me actually pull this up. Selecting the group at index 0, selecting the group at index 1. Okay, so we can clearly see now every time we loop on the outer loop, we can see that that's happening. So if we want to see what's happening with the inner loop, let's go ahead and add something for that as well. So just inside this inner loop here, but before the conditional. So because I want to make sure that this prints on every single loop of the J loop. I'll say checking the character at index J. Okay. And then inside here, I'm only going to print that I found her if I find her. So I'll say, found her. She has the plans. Okay. Otherwise, we could say, let's print something else instead so we can still see what's happening. And I'm just going to do this for the sake of us being able to see what happens when we don't find her. And we'll say, I'm tripping here. Wow, what am I doing? So what happens when we have extra long lectures? I start losing my mind. Okay, nope, that was, and we will, because this is a temperate literal, we'll go in and say that was characters at index I at index J. But we can name the specific character in this group of characters that we're looking at. All right, let's do it. And I'm just gonna come up and run it, and then I will say, yeah, we're at cell block 2100. Great. Okay. So we have a very long thing happening here now. All right. So selecting the group at index 0, checking the character at index J. Nope, that was Cassian Endor. Oh, I have a mistake. Something did not work right. It says J every time, and that's not what I meant. Oh yeah, I'm missing my. I don't have the correct syntax there for my placeholder. I was missing the $sign. Okay, let's run it again. Okay. At index 0, nope, that was Cassian Andor. Nope, that was Jen Urso. And then it keeps going through and checks all of those and says, nope, didn't find her. Goes through the next one. And we can see, if we go back and look at these original things, we can see we're at index 1 now for I, but we're going through each of these characters in this array. And I realize now that it might be confusing when I'm saying characters. I'm talking about movie characters. I am not talking about string characters. Okay. We're just evaluating strings at this point. Yeah, and so then we say, okay, let's keep going, and then we find her. We finally get to her in the group that is at index 2 in the outer array, but it's the character at index 1 within that array. Right here. And that was when it was actually giving us characters at index 2, at index 1. And that's where the double bracket notation comes in handy. And you can actually see that. Okay. Does that help? Anybody got any questions about that? Yeah, it's a little mind bending. It's all right. It'll get easier. Your IAs are going to help you get through Studio today, I promise. They remember what it was like. Okay. So I have a bunch of practice for working with loops and different types of loops and levels of looping. The more complex ones are here, so you can find those on my website. Also, again, I have these graded assignment prep tutorials that I did with a live tutorial with videos and everything. If you'd like to do those. Coming up, we have functions tomorrow. You'll have a graded assignment workday on Wednesday, where you will work on part 2 and beyond. If you get part 2 done and you want to go ahead and work on part 3, great. But you definitely want to try to get part 2 done. And then I will do another one of those little review sessions after the check-in in the afternoon that day. Chapter 11 is on Thursday, more on functions. So we'll dive a little deeper into functions. And then Friday is your graded assignment workday for that final part of the graded assignment 1. You need to have it done by 5 p.m. And there will be a self-assessment exam that day if you're ready for it. Otherwise, you can put it off in favor of getting the graded assignment done. All right. For Studio today, you're going to do the Chapter 9 Studio, looking at 5 different types of food and then 6 different astronauts. And you're going to need to make it so that you can put together these meals for each astronaut using one item, but each one should have a different meal. So you'll do that initially, and then in part B, you're actually going to get user input so that you can get a variable number of meals to create. Maybe you're creating 2 meals or 5 meals. And then you will put in a little bit of validation to make sure that the user is giving you a number you can work with. And then if you get to the bonus mission, that is generating a password from 2 different strings. Fun little exercise. There is an error in the instructions that the ed team is planning on fixing soon, but it hasn't been fixed as of today. So it's going to tell you in a couple of places to run your file with node solution, because solution.js is where you're putting your code, but you actually just need to run node index, because ultimately that's the one that executes. So if you get confused about that, just talk to your IA. You'll be good.